Hi everyone, this video is to demonstrate that indeed I do have flyback that is coming off the rotor coils, and I'm not too sure why that is a doubt, but this video is to demonstrate that. So at this time I have an input voltage of around, well, it's saying 16 there, but as soon as I put this motor on load, it'll be in the 12 volt range. And this is the current again, and this is my input, the variac, through this 3900 farad capacitor, and these here are both 3900 filtering capacitors, and that is a 1 ohm shunt there to measure the voltage across it on this meter, which turns into basically current. So we have our PWM or the signal generator set at the same 900 hertz frequency, and we have a 50% duty cycle, again the same. So I have this capacitor here, which is the same capacitor, 400 volts, 3900 microfarads, and that is what is going to be connected to the flyback diode here coming off the rotor coil. And then I'm going to make this connection here to be the final bridge. So I'm going to go ahead and okay, so here we have our meter here, voltage meter on the capacitor, and I'll just short that and you'll see the voltage goes to 0. So that's 0 now, and I'm actually going to just go ahead now and hook it up. So that is the negative side, which is the opposite, the positive side coming in. That's the negative, and the negative now becomes a positive here on the flyback diode. Very basic. So now I'm going to start it just by connecting this here to my positive side here. And there is our capacitor. I connect it. So the motor won't turn because it needs the stator coils to be operating. And as you can see, the voltage is climbing fairly fast on that capacitor. So if the circuit was being fed by the input, which is 12.24 volts, we should be having the same voltage on the meter. But as you can see, our input voltage is 12.25, and now we're up to 15 volts there. That is the current going in, 0.48, 480, 490 milliamps, and everything is the same here, except the motor won't turn because the stator coils are not connected now. We're just using the flyback going to fill this capacitor here. So there you go, we're at 18 volts and still climbing. And I've tested this for a little bit before doing this video, and it climbed above 100 volts. So I'm quite sure it'll keep doing the same thing. And there you go. Oh, sorry. I was thinking that was 20 volts. We're actually up to 207, 209 volts. So, and it's still climbing. So obviously this is flyback energy going to fill that cap. There's no problem. The capacitor is 400 volt rated, so 220 volts across it, and my meter is set to DC if this is correct. So sorry, I didn't notice that climbed that fast. So there you go. This proves that ultimately we do have flyback there, and I'll stop the circuit now. And I need to, well, I don't want to short that cap because that's going to be pretty explosive. So there you go. We most likely can reach easily 250 volts, maybe 300 volts on the capacitor. So no need to go any further. Obviously it's flyback going there. So now we can just unhook my capacitor here. Be very careful not to bring the two terminals close together, and I will re-hook up the flyback diode now to the stator coil. So the stator coil now is hooked up on the flyback diode, and let's start this over again and see. Oops, sorry, wrong connector. So there you go. Motor starts to turn immediately, and there you have it. So there I can raise the voltage. We're around 12 volts there. It's 14 volts, 1 amp. And sorry for the movement, there's actually mosquitoes around here, and I'm being bitten here as this is happening. So everything is the same here, and our flyback now is being directed in the stator coil. Our bulb is there, fairly bright, and we can disconnect that bulb. There's our current, and the motor drops in RPM and the current stays exactly the same. So I couldn't understand how that wasn't clear, that, you know, that somehow this was the input power going in. How can you put a bulb on load and it not affect the input? You know, obviously you cannot do that. Or make it dead short, which I did. I'll do it again. I'll make it dead short with the bulb. And you hear it spinning off again. And there you go. Just slightly a little bit more current, but nothing to speak of. And we've got, you know, lots of torque there. There we stop our flyback going to the stator coil. Stator coil is disconnected, motor comes to a stop, and I don't want to keep it like that too long because the flyback is going to really heat up the MOSFET here. And I will reconnect the bulb. So the bulb now is connected. Current is back. So what we can do, we can just keep raising the voltage, and change my meter settings here. And what we can do is we can drop down the duty cycle and raise the voltage even more. We'll put a 20% duty cycle, and let's give this puppy a try here. So we are now at let's bring that to 40 volts. So at 40 volts, we have 430 milliamps and 20% duty cycle. And there's our bulb lit. And I will now take the bulb off. Bulb is off. It is consuming more current. Bulb back on. Take the stator coil off. I'm not going to do it for very long. Motor comes to complete stop. And obviously here, if you're seeing the sparks, that is flyback. You cannot see sparks like that, and it showed that in my first video, so I have no idea what the doubts are about. Okay, so I think enough ranting about this. The effect of circulating the flyback from the rotor coil is a valid effect. I could boost that further, will give you 50 volts. But my brush here is probably going to melt off. I just have it hot glued. This brush here doesn't heat up, but this one does. It might stop. And there we go. We're having a fluctuation with the bulb there. And actually, if I change the frequency, I can stabilize it. See there? I've actually dropped the frequency. So they're raising the frequency and I'm dropping the frequency. So there at, you can see the pulsing there, that's 920 hertz. And that there is 900 hertz right there. And then if I drop faster. So it does different things at different frequencies and different voltages. The bulb is back. That bulb is pretty well fully lit with that. So anyways, interesting stuff, and hopefully we can continue working together and not doubt ourselves. Thanks. Bye now.